lesson. Today our lesson is talking about the law of the conservation of momentum. The law of conservation of momentum states that when a system of interacting objects is not influenced by any outside forces, the total momentum of the system cannot change. That means if you have two objects, like this man here throw a rock. Now, before that is throwing the rock, he have the rock with his hand. So the velocity of the rock is 0, and the velocity of the man is 0. So that the velocity of the momentum before he is throwing the ball is 0. After he throwing the ball, the total momentum of the rock and of his body is 0. That means the momentum of the system cannot change. The momentum before equals the momentum after. Let's have now 4 examples. So if you throw a rock, this is one of the examples of momentum, that if you throw a rock forward from a skateboard, as you see in this picture here, you will move backward in response. Try it. You are on a skateboard. You have a rock in your hand. So the m times v for you and for the rock is 0 because the velocity here is 0. So here we said we have m times v for the body and for the rock. You with the rock, your mass is, as an example, 80. And the velocity, since you are not moving, is 0. So the momentum before throwing the ball, before moving, is 0. After you throw the ball, the rock is moving, and your body also is moving. Sorry. You are moving, the rock is moving, and your body is also moving. But the rock is moving with a different velocity. That the rock is moving with different velocity than the velocity of your body. But the summation of them is 0. That's why the momentum before throwing the rock equals the momentum after throwing the rock. Before equal, after in the system. Let's have examples here. Now remember this girl. How did my sister get this huge bump and black eye? She have here a gun with her hand. She press on it, but after she make this, she found that she has a huge bump and black eye on her face. Later on, we will see that why is the girl look like this. Now, the law of conservation of momentum states that the total momentum of all objects, interacting with one another remains constant regardless of the nature of the forces between the objects. 1 minute, please. I will come back.
Touch your mouth, yes or no? No or no? Yes or no? Because like what?
I'm so sorry.
It's okay, teacher.
The total momentum of all objects interacting with one another remains constant. So here, or in other words, the total momentum of a system will stay the same before and after a collision. So this is very important one, that the total momentum before equals the total momentum after a collision.
Teacher,
This is the law of conservation of momentum. Yes, miss?
teacher, when a force applied on this velocity, then the velocity will change. So I don't understand like how it's equal. It still will be equal.
Wait, later on I will give you examples. But
Yeah.
before that, here you have to know that the law of conservation is like conservation of, as we have conservation of charge, as we have conservation of energy, as we have conservation of momentum. The momentum will stay the same before and after the collision. Let's see now how it will be in examples. Remember this girl? How can you try to explain that my sister has a black eye using the law of conservation of momentum? We will explain it why. Now look at this example here. Miss John, as he is moving on the ice before collision, look at the example here before collision. He has the ball in his hand and he's moving on the ice. So the momentum here is 0. Why? We said before that the momentum is the product m times v. M times v. This is the momentum. And he's not moving. So the velocity is 0. It is mv. And since he's not moving, so the momentum here is 0. Is it clear here?
Yes, teacher.
Okay. So the P, or we'd say at the M momentum total is 0. This P, or you can say it is M. Now, look at this, the second one. After the collision, after he threw the ball, what happened? Look at the ball. The ball is moving forward, but his body is moving backward. So the velocity for the ball is 5, and the velocity for his body will be -5.
Oh, yeah.
That's why the summation of the momentum will be 0. So here the momentum will be 0 because
Teacher,
the momentum, the total momentum here for the ball, for the velocity, the total momentum will be 5 kilogram meter per second, and the velocity will be -5 kilogram meter per second. The total of them will be 0.
teacher, they are both the same because it's like the Newton's second law that force equal force.
Yeah, third law, yes, exactly.
Okay.
So that the total momentum here is 0. This is the meaning of conservation of energy. Momentum. Before collision, you have 0 because I have the mass of the rock is 1 kilogram as an example, and the mass of Mr. John is 60 kilogram. So here we have 61, the total masses, times the velocity, which is 0. So the total momentum here is 0. But if you look at the second example here, you have the velocity, the rock will move 5 meters per second, and the mass of the rock is 1 kilogram. So 1 times 5, we have 5 kilogram meter per second. This is for the rock. But look at the Mr. John. For Mr. John here, his velocity was let's say as 1/12, as an example, or any number, 0.08. His velocity is 0.08. The velocity, which is 0.08, times his mass, which is 60. If you multiply them, you will find that the answer is 5. But it's -5 because he's going backwards. So the total momentum of the rock, which is going to the right or to the forward, plus the momentum for the Mr. John to the back, adding them to each other, you will find the total momentum is 0. Is it clear?
Yes.
Teacher.
يلا 1
Yes.
minute and I will write back. Okay, now let's continue. So why does, now let's see the explanation. Why does Mr. John move backwards? Mr. John moves backward because he threw the ball forward. Why he's moving backward? Because he threw it forward. Explain the relationship. The law of the conservation of momentum states that the total momentum of a system must stay the same before and after. Before the ball and Mr. John had a total momentum of 0. So before the collision, the momentum of ball and Mr. John is 0 or are 0. But the total momentum, and since we have the conservation of energy, so the total momentum of him after the collision must be 0. How it can must be 0? By moving the ball forward and let Mr. John moving backward. Like 5 and -5 will have 0. Is it clear?
Yeah.
Yes. Teacher.
Now support with data. When the ball moved forward, it had a positive momentum. So Mr. John needed a negative momentum to cancel it out. This is why he moved backwards. Since he have a positive momentum, he must have another momentum to cancel it because he must get a 0. How he must get a 0? By making a momentum that cancel the momentum of the ball by making a negative momentum. So they cancel each other. That's why we're moving backward. He is moving, backward. Is it clear, Miss, the definition? What's the meaning of the conservation of momentum?
Yes.
Yeah.
Now look at these two man and woman here. Why do both skaters move after? At the first one, here we have m1 plus m2. So before momentum here, we have m1 plus m2, and they have the same velocity, which is 0. They are not moving. After they push off each other, the first, or the girl here or the woman here, she has her mass, okay, with velocity v1, and this mass, it must equal the mass of the product of the mass of the man times his velocity, but in different sign. That's why when you add them, you will get 0. So sometimes if you push them, maybe the man, his weight is greater than the woman. So since he has a greater mass, so he will move a velocity less than the velocity of the woman. That's why also if you see this example here, maybe he is come to the back with small velocity relating to his mass, but the mass of the ball is very small, so it will move with greater velocity. So here, this is before collision. They are 0. After the collision, they also 0. That's why the total momentum before equal the total momentum after, which is conserved, or which is the total moment, the conservation of energy, of of momentum. Sorry. So before, the momentum is 0 because it's not moving. After, there's also the momentum is 0. Why? As I told you before. Now let's explain why do both skaters moves after. They move after in order to conserve momentum. They must move like this after the push off, one to the right, one to the left, or one backward, one forward, in different order. Why? To make to accomplish the conservation of momentum. Let's explain the relation. The law of the conservation of momentum, as we said, states that the total momentum of a system must stay the same before and after. Before, the two skaters has a total momentum of 0, and after the collision, the total momentum, it must be 0. That's why one move to the right and one move to the left. Is it clear?
Teacher, this is only in the state when the velocity is 0, right?
For what?
For this conservation of momentum, only when the velocity is 0?
Yes.
Okay.
Now, when they push against each other, one move forward and have a positive momentum, so the other need to move backward to have a negative momentum. So the total momentum stayed 0, as we discussed before. Look at this example here. Here now, you have a gun. You can have this example here. Now, recoil is a term that refers to a moment when a gun moves backward after a shot. Now, all of us know that this is a gun, and inside a gun we have a shot, let's say, okay? Now, before recoil, here you have in Arabic, I think, طلقة. تعرفوا يعني طلقة؟
Yeah.
Yes.
Okay. And here you have المسدس. So before collision, الطلقة هاي جوا المسدس. After he push, لما يجي بده يطخ اللي okay here sometimes you will find that this هاي الطلقة هي تطلع لقدام بيعمل انفجار، بس الشيء اللي جوا بيرجع لورا. Why? Because النار اللي حتطلع او الريكويل هي حتعمل تطلع لبرا وحتعمل اذى، بس في شيء حيرجع على عين البنت زي ما شفنا قبل شوي.
Yeah, the opposite.
Yeah. If you see this example here, let's have this example. This will be more clear, inshallah. Here, this picture here before momentum. It is inside the cannon, or the cannonball here, it's inside the cannon. But after that, when the cannonball is going forward, when it's make a blam, there's something that's going to the back in the cannonball. Okay, لما هو بيطلع لقدام في شيء بتلاقيه بيرجع لورا. Let's make a recall. This one because of momentum, because there's the mass of the cannonball times its velocity. They have a momentum. The ball or there's another cannonball inside here, the cannon. It must give you the same momentum but in opposite magnitude. That's why it's come backwards.
And this force that is applied, it will make the opposite, so it will apply in this shot again. So they will be in opposite directions and the same magnitude.
Yes. So here, recoil is a term that refers to a moment when a gun moves backward after it's a shot. And after it's shot. Recoil happens because everything must follow the law of conservation of momentum. So after you shot this shot here, when it's gone forward, the recoil will make this one here, we call it a recoil. It's gone to the backwards with a certain momentum to cancel the momentum of the shot. That's to make the conservation of momentum. So why a gun recoil? So why a gun recoil here? Because the total momentum before was 0. So the total momentum after has to be 0. How it has to be 0? If it's go back forward, the recoil must make a momentum with different direction with the same magnitude to cancel the momentum to the forward. Let's see now this girl, if the gun moves with a negative momentum, because the bullet moves with a positive momentum and they cancel out, so the total momentum stays 0. This girl here, why her eyes look like this? Because when she push the gun goes forward, but the recoil comes to the backward and push and touch her eyes. That's why she has a huge bump on her eye. Is it clear?
Yeah.
Yes. But teacher, can you repeat this last thing that you said?
For the girl?
Yeah.
Okay.